Okay, so this is I think the fifth class. uh, this is not actually a theory class. I will say some theory regarding pull-up resistor, and we will go to programming. So pull-up resistor is nothing but a resistor connected to a switch. This kind of resistor connected to a switch, and the switch is again connected to ground, so that the 5 volt is not directly goes to the ground, but as we know that resistor opposed to the flow of voltage through it, as we know that the B equal to IR and I equal to voltage by resistance, where the resistance opposed to the flow of voltage through it. So as it opposed, the currents will be, whatever obtains will be low, and whatever obtains here is currents according to the relations. So because of that, the currents obtained here will be something lower. Okay, so and switch need low currents. Because of that, this resistance is put here. So please kindly understand that is the purpose. And this resistance is put here because this 5 volts is needed by the microcontroller, 5 to 3 volts, but the switch doesn't need that much amount of voltage to operate. So because of that, the resistance is put here. That's all. And this the code that we are going to write, or most of the code that you will find, doesn't have a pull-up resistor in the circuit. This is the ARM Cortex M4 microcontroller that we are using always in our code, right? So this is the PF 0 pins, port F 0 pins, and we are connecting this resistance here and the switcher and the ground, but here is no pull-up resistor. Okay, so because of that, it need to use, there is no pull-up resistor in the circuit, so because of that we need to use this pull-up resistor. This GPIO PUR is a pull-up resistor, 32-bit, as we know that ARM Cortex M4, ARM Cortex processor always has a 32-bit resistor. And so these are the bit D0 to D8, the rest is reserved. So if you use port F pin 0, that we are using your port F pin 0, right? If you are using port F pin 0 means then you are going to enable the bit D0. Likewise, if you use port F pin 1, then D1, pin 2, then D2 respectively. Okay, like that. D0 to D7 are used to enable or disable the pull-up resistor for pin 0 to 7 of the port. As I mentioned, if you want to use pin 0 of the port F, then you have to use D0, okay, and set it to 1 to enable the pull-up resistor for whatever pins of the port you are choosing to write in your code, as because it says 1 to enable the pull-up, 0 to disable the pull-up. Okay, why we are using this resistor? Because the circuit we are going to because this circuit we are going to use, by this circuit we are writing a program, right? This doesn't have a pull-up resistor, so that's why we are using ARM Cortex M4 pull-up resistor GPIO PUR. Okay, that's all and nothing else. So we will come to the code as it we use TM4C123GX 6PM always in our code. Okay, so we will write the code. This is the main function in the code. We took a variable, and that is of int type, variable called value. Unsigned means neither not giving any kind of sign. That usually it refers to positive value. This so here we are choosing this RCGC GPIO means choose a particular port, and this 2 represents this in hexadecimal and 0 represent this. So we are using port F, right? A, B, C, D, E, E, F. So this is port F. So we are choosing port F, right? Or GPIO F. And here in this we are choosing the direction. What does the direction register says? To choose an output, right? So which pin we are choosing the output? 8. 8 means what? 0 represents in hexadecimal as this, and 8 means this, right? So we are choosing the pin pin 3. This is pin 0, 1, 2, 3. So pin 3. Okay, we are choosing the pin 3, and then GPIOF. So here we are making the digital pin as 0x18. 1 means this, and then 8 means so. Because we have chosen this pin pin 3. 8 means pin 3, right? In hexadecimal it is written 8 as like this. That means it is pin 3 because we have chosen it for output. And then here we are choosing we are setting this pin 4 yes, this pin 4 as input pin. We are not using any analog here, so we are setting it as digital pin. And then this one is pull-up resistor. As I mentioned just now about the pull-up resistor, this pull-up resistor is needed in the input connections. So in the input, not in the output connections. So as I mentioned here in the diagram, in the input connections, where the switch is there. When the switch is pressed, it will be connected to the microcontroller, and then after that it will connect to a lead. So this is input area and the lead will be output. So because of that, so this one is input area. Pull-up resistor is in the input sections, this one, and it will be connected here to the microcontroller. So that's why. So input pin is pin 4, right? This one. One is represented as so that's why pin 4. So we have written one here, one is represented in hexadecimal as this because of that. Well, means execute this process. Okay, so here value equal to GPIO. Here we have taken one variable of the integer value. Okay, so this is the value and is taking data from the GPIO. That means we are reading the data from the switch. When the switch is pressed, we get some data as input data, and then it is connected to GPIO app. So GPIO app is pin. We have chosen pin number pin 4. Okay, so in the pin 4 of port F, GPIO F, the data is collected and is stored in this variable value. And here we need this is the we take negations of the of this value because this data is coming from the switch. This data is coming from the switch. This data is coming from the switch, and some switch are on. Usually switch are on by 0 bits. When you put 0 and not 1, because of that. But the lids are on. Lids are on when, by putting by supplying 1. Then is switch are on when you put data 0. These are on when you put data 1. It means so as you are getting the input data from the switch, it is 0. But for lead we need 1, so we take the data store 0 negation so that it becomes 1. Here we shift to right. Because we have to display it on the LED. The value, whatever you get is from the pin 4. It's from the pin 4, Where is, oh yeah, here is from the pin 4, but the LED is on the pin 3, so we need to shift, okay, 1 to the right so that it becomes the pin 3. And then okay, here okay, we store okay the value so that it becomes okay when we shift 1, that's because the values are coming like 1 1 0 0 0. Okay, the values are coming like 1 0 0, but if you shift okay 1 to the right, the values are now right. So okay, because the lead is connected to this pin, so the lead need to be turned on. That's why we shift 1 right. That's why now okay, since the value is like this, we are okay putting the value to the GPIO F. That's why I believe everybody understand. So that's all. And then it is a little okay, pay attention, because I'm explaining here little okay things that need to be understand. So this is not so important. This is just saying this system has a restore CPACR and it supplies okay, values F, and the F is stand for okay 1111, and it activate the it said the 2 core processor C11 and C10 with enable the ARM coprocessor to use the floating point units of the system, because when you write the code you may be using double or float values. So that's all for this session. Thank you all.